Okay, we have here today another interesting integral from the Berkeley integration bee 2020. This was problem number 5. We have the integral from 0 to 1 natural log x times sine natural log x dx. Okay, I thought this was an interesting problem, and I'm definitely thinking integration by parts could help us out. But actually, what I want to do before I do that, I think I'm going to do a u substitution just to kind of clean it up, make it a little less scary by making my u substitution for natural log of x. And then with that, what I can do, just to solve for x, I can write x as e to the u. I'll take my derivative and we'll find that dx is going to be eu du. And we'll just go ahead and we'll make this substitution. So taking a 1, natural log at 1, our u value is going to be 0. Taking 0, natural log of 0, well, that means our u value is going to minus infinity. Then for natural log of x, that's just going to be u. Then here we're going to have sine of u, and our dx value is going to be just eu du. And then this is, I think, where it gets really interesting. This is definitely looking like integration by parts, but the unusual thing is we actually have 3 functions. We're used to doing this kind of thing with 2. Any 2 of these would be kind of normal integration by parts, but we get 3 functions. That's going to make it a little bit more complicated. Okay, for integration by parts, I'm going to go ahead and do this by the DI method, or tabular integration. And I'm going to choose to integrate EU and differentiate u sine u. Now, of course, integrating EU is easy. We're going to have EU down here on the right. Now for u sine u, we're going to do the product rule. So integrating u is going to give me 1 times sine u. And then integrating again with the product rule is going to give me u cosine u. And then you could take this column and try to integrate it, but I'm going to actually just differentiate one more time. So derivative of sine u is going to give me a cosine u. Derivative of this is going to give me cosine u plus, then derivative of u cosine u is going to give me u, derivative of cosine u is going to give me minus sine u. I'll bring the minus out front and write it like this. And then we're going to have part of our solution here on the diagonal. So let's look at that. But when I do that, I'm actually going to factor out an e to the u because we have it in both these terms. And then I'm going to write it as u sine u. We'll have a minus sine u. And then we're going to have another minus u cos u. I need to evaluate from minus infinity to 0. And then we're going to be integrating this here. Now we have 2 cosine u's here, so I'm going to put those together, of course, and have that as 2 cos u. So then here we're going to have an integral. We have a plus sign here, so I'm going to do plus, bringing the 2 out front, cosine of u, eu. And then here we're subtracting this one, so we're subtracting a u sine u, eu. Okay, now before we deal with these integrals, let's evaluate this part up here. So first evaluating at 0, when we plug a 0 in here on the u, that's a 0. When I plug in 0 here, sine of 0 is 0, and then a 0 here is also going to be 0. So all the 0 terms are 0. And then for the minus infinity, let's just plug it into e. So e to the minus infinity is going to 0. Technically, we should do a limit here, but you can see that for e to the minus infinity, that's going to be going to 0. So this whole thing here is going to 0, and we can just focus on these 2 integrals. Now for my next step, what I'm going to do, let's just label this integral I. Of course, that's the same thing. This is our goal. This is what we want from the beginning. So that's our I, but then notice this here is the exact same thing. So what I can do basically is add this integral on both sides. So I'll add one here to cancel this, but then we'll add one here. So then on the left side of our equation, we're going to have 2i, and then we're going to still have this piece right here. We're going to have 2 in this integral of cosine u eu. But now that we've got a 2 on both sides, I'm just going to divide those off. So now that we've isolated back just our original integral I. And let's see if I can squeeze this in. So I'm going to bring it back up here because I got some space now. So now for our solution, we're just going to need to integrate. And this is now much simpler, right? We're just integrating cos u eu. And so what do I do now? Just going to do integration by parts again. So I'm doing DI method all over again. I think I'll switch it up and differentiate EU this time and integrate cosine u. I don't know, I like doing it that way. So when I integrate cosine u, we're going to get sine u. I differentiate EU. We're going to have EU there. And I can stop here, but actually let's just do this one more time. So if I differentiate again, we get another EU. This is going to be integral of sine u is going to be minus cosine u. So we'll have part of our solution on the diagonals. I'll factor out the EU. We're going to have a sine u here. Now minus times minus is going to give me a plus. So we're going to have here a plus cosine u. We're evaluating this from minus infinity to 0. This here is going to be just the integral of cos u eu. But another fortunate thing that just happened there, this here is actually the same thing as our integral here. And because it's the same as our solution, I can actually call this I as well. So we're going to call this I, we're going to call this I. Do the same trick all over again where we add I on both sides. And so that's going to cancel here. And so we're just solving for 2I, but I think I kind of made a mess and I need a little more space. Okay, now finally we're ready to evaluate this thing and finish it off. So let's take our upper bound 0 and plug that in. Sine at 0 is going to be 0. Cosine at 0 is 1. E to the 0 is 1. So our first term is going to be just a 1. Then next we need to look at the limit at minus infinity. We can look again, the same thing we did before, we can look at e to the minus infinity. The limit of that's going to 0. So we just have over here 1 minus 0, which is equal to 1. So this is equal to 1. All I need to do is divide by 2 on both sides. And we have our final solution, just 1/2. Okay, that was a pretty good problem. We just needed some patience with the integration by parts and doing it twice, and it wasn't too bad. So we'll stop it there. Thanks everyone for watching. Have a great day.